Hello my excellent A students. In this video we will be looking at division in modular arithmetic, but it is our usual practice. We start off by solving the take-home question from the previous video, and the questions were: question 1, to find 4 times 7 in modulo 8. Question 2, 6 times 9 in modulo 5. Question 3, 19 times 28 in modulo 9. So to solve this, let's start with the first question, question 1. 4 times 7 will give us 28. 28 is not a valid mode 8 residue. Valid mode 8 residue is from 0 to 7. So for us to get this, we have to divide by the mode 8. 28 divided by 8 will give us 3 remainder 4. 4 times 7 in modulo 8 would be 4. Question 2. 6 times 9 will give us 54. In modulus 5, the valid residues are 0, 1, 2, 3, 4. So 54 in modulus 5 is 10 remainder 4. So 6 times 9 modulus 5 is 4. And the final question, question 3, 19 times 28 would give us 582. In modulus 9, the valid residues are from 0 to 8. So 582 divided by the modulo, which is 9, would give us 59. Remainder 1. 19 times 28 will give us 1 in modulo 9. And that is that on the solution to the take home. So we move to today's video proper. Example 1. Question 1. A. 12 divided by 9 in modulo 6. So assume that 12 divided by 9 will give us x. So 12 divided by 9, we assume that to give us x. So 12 will be equal to, when you cross multiply, 12 times 1 is 12, 9 times x, 9x. We have to add something to it such that it is a perfect multiple of 9, and such that we can divide 9 by it without remainder to get our value of x. So how do we do that? We just say 12 plus 0 is equal to 9x. But remember, we are working in modulo 6, and in modulo 6, 0 are possible values of 0 in modulo 6 are multiple of 6. So this 0 could be 6, it could be 12, it could be 18, and all like that. Now because we already have 12, if we pick the least value of 0 here, which is 6, and add it to 12, it will give us 18. And 18 is a perfect multiple of 9. So we can divide 18 by 9 and we get the value of x. So that is exactly what we will do. So we will now say 12 plus 6 will now be equal to 9x, and 12 plus 6 is 18 is equal to 9x, and then we can divide both sides by 9 to get the value of x. So x will then be 18 divided by 9, which is 2. Therefore 12 divided by 9 is equal to 2 in modulo 6. C. 23 divided by 7 in modulo 4. We assume that 23 divided by 7 is a number q, and if we write it like this, q over 1, we can cross multiply. So we have 23 times 1, 23 is equal to 7 times q, 7q. We need to change this 23 such that it is a multiple of 7 that is divisible by it without remainder. So we add 0 to it, but values of 0 in mode 4 it could be 4, it could be 8, it could be 12, it could be 16, and like that. So if we pick 4, 23 plus 4, 27. 27 is not divisible by 7. 23 plus 8, 31 is not divisible. 23 plus 12, 35. So that is it. So we say this is 23 plus 12, but 12 in mode 4 is actually 0, so it doesn't change anything. So this becomes 35 is equal to 7k. 35 is equal to 7k, divide both by 7. We have q is equal to 5. But 5 in modulus 4, 5 is greater than 4, so we have to convert it to a value recipe. So that will be 5 divided by 4, and that will be 1 remainder 1. So q will actually be 1 in the modulus 4. So therefore 23 divided by 7 is 1 in modulus 4. Question 2 says 9 minus 5x is equal to 13 in mod 7. So the first thing we want to do is to collect the like terms. So, and the safest way to do that is to bring this minus 5 to jump the bridge. When minus jump, it becomes plus. So we have 9 is equal to 5x plus 13, that is here. Then we bring this plus 13 to 9. It becomes 9 minus 13 is equal to 5x. Remember, I explained in one of the previous videos this concept that when you have a negative and positive like this, if there is no sign in front of a number, there is an implicit plus sign there. 9 minus 13 will actually give us minus 4. Why? Because 13 is the larger number and has negative sign. So our answer will be negative. So minus 4 is equal to 5x. You see that this is minus 4 in 5x and we are working in modulo 7. So the first thing we want to do is to convert this minus 4 to a positive number. To do that, we add 0 to this. 0 in modulo 7 could be 14 and on. So if we say minus 4 plus 0, it's the same thing as saying minus 4 plus 7 because we are working with modulo 7. And in modulo 7, 0 is 7. Because 7 divided by 7 will be 1 remainder 0, right? So 7 minus 4 will give us 3 is equal to 5x. Remember, we are still working in modulo 7. Now, for us to get what 5x will be, we have to change this here to a multiple of 5 such that when 5 is divided by it, we get a value without remainder. So to do that, we assume that we're adding 0 to it, and 0 in modulo 7 is multiple of 7. It could be 7, it could be 14, it could be 21, and on. So we pick the smallest number to make this solution feasible. So if you add 7 plus 3, that's 10, and 10 would 5 is divisible by 10. So we say 3 plus 7 is equal to 5x. That's 10 is equal to 5x. So when we divide both sides by 5, x gives us 2. So 9x is 2 in modulus 7. In 2b, we have x plus 2 is equal to 0 in modulus 3. So this is x is equal to, when plus 2 comes out, it becomes minus 2. In modulus 3, to change this minus, just add 0. 0 in modulus 3 are multiples of 3. So let's pick the first smallest one to make this positive. Minus 3 plus 2 gives us 1. So x is 1 in modulus 3. Next to 2c, we have 7 minus x is equal to 9. So we have 7 is equal to, when minus x crosses, it becomes plus x. It adds a plus 9 here. Don't forget, this is in modulus 8. So 7 plus 9 comes here, it becomes minus 9. So this is minus 2 is x. So x is minus 2. So we are working in modulus 8. So we assume that we want to add 0 to it. but 0 in modulus 8 are multiples of 8. It could be 8, it could be 16. We pick the smallest number to make this solution feasible. Yeah, that's minus 2 plus 8, and that's 6 modulus 8. And final question, we have 4 minus x is 7. 4 is equal to x plus 7. Note that this is a modulus 5. So 4 minus 7 is x. Minus 3 is x. So minus 3 plus 0 is x. 0 in modulus 5 could be 5, could be 10, and all like that. So we pick the smallest, which is 5. 5 minus 3 is 2. So x is 2 in modulus 5. The take-home question for this John 1, 8 divided by 5 in modulus 4 question 2, 69 divided by 12 in modulus 15 question 3, x minus 5 is equal to 1 in modulus 3. I hope you enjoyed this video. I hope you understand the concept. Remember, if it didn't make sense the first time, watch it again. That is the MathSense way. I'll see you in the next video.